Hello students, welcome to the learning platform of Paritran classes. Today we are going to discuss projectile motion. So before going too deep into the topic, we will understand why we are studying projectile motion and where it's going to help us. So take the example of cricket, right? Sometimes whenever batsman hitting the ball, it's going very high. Sometimes whenever batsman hitting the ball, it's going very far, right? When it's going high, obviously batsman will get catch out, and next time when it's going far, definitely it will be six. So what's the reason behind it? If we have to understand, so how you will understand this reason behind these two phenomena? Definitely for that understanding, you have to study projectile motion. Next, if a fighter jet is moving and fighter jet has to hit a target of enemy, right, enemy base, definitely he will drop a bomb and this bomb will hit the enemy base, right? But at what time exactly the fighter jet has to drop the ball, that understanding also you will get by study of projectile motion. Also, suppose a javelin throw, in game of javelin throw, if the player has to throw a javelin so it can go maximum distance, right? At what exact angle he has to throw the javelin so it can travel the maximum distance? If you have to calculate how you will do it, for that purpose also you have to study projectile motion. Clear? So projectile motion is very important. Either you have to study this one, defense, or you have to study about sports. In all field, projectile motion will help you. Clear? Okay. So now come to this outline of this complete class. First of all, we will discuss about prerequisite. What's the prerequisite required to understand projectile motion? Then we will discuss what is projectile motion is. Okay. Next, we will discuss assumption for calculation, like some assumption you have to take for calculation, like some ideal situation. So what will be that ideal situation? Then we will derive some formula. We'll discuss about graph, some question we will practice, and also one thing we will discuss, radius of curvature. It's not very common, but still sometimes it is coming in exam, so you have to study this. And then we will discuss, so what's the actual scenario or actual problem we are facing when we are observing a projectile motion. Some other natural factor is coming that generally we are not considering while basic calculation, right? So that we will discuss, and finally we will do revision of this lesson, right? So now come to the prerequisite of projectile motion. So these all are the prerequisite that we have to know before moving into the chapter of projectile motion, like concept of scalar and vector, basic equation of kinematics, and all you have to know before going to the chapter of projectile motion. Please go through it, and if you don't know any topic, please let me know so I can explain you here before going to this chapter, right? Okay, so I hope you have clarity of these all points. Now come to this projectile motion. Okay, what is exactly projectile motion is, in a very simple way, okay, without any definition and all going to bookish definition. If we have to understand what is projectile motion, if suppose we have object, if we'll throw at any angle, it will go some height and again fall down. This motion of the object will be projectile motion. Like similar case here, you can see a player hit the football, right? And football is going in this trajectory, right? So this trajectory is what? A projectile motion. Or what's the shape of this? Shape of this is what? Parabola, right? Clear? So this is projectile motion, right? But again, if we'll see some consideration also, we have to understand in which case object will be projectile, we will consider projectile motion, in which case we cannot consider the motion of object as a projectile motion is, right? So if we'll go through the bookish definition, projectile motion is the motion of object that thrown or projected into the air at an angle with horizontal, right? And it's move under the influence of gravity only, without any propulsion after initial launch. So this condition also very important, without any propulsion after initial launch. Propulsion means what? A thrust force, like whenever we are launching the rocket, how the rocket is moving far, or how the rocket is moving, the gas that is coming out from backside of rocket, it provide a propulsion to the rocket, and rocket is moving with the help of propulsion force, right? So that we cannot consider as a projectile motion. Okay, so now the basic point of projectile motion is what? Motion must be two-dimensional, right? Two-dimensional means, yeah, see, motion under gravity, if we are if it must be two-dimensional. If you will throw this cap upward, right, it will again come down into my hand, okay, on my hand. So it move up and it move down on a same trajectory, same line. So it's a one-dimensional motion only. Why? Because object is moving in one line. Clear? So this will not considered as a projectile motion. Understood? Here two dimensions are required, means object must have to travel along two axes. Clear? Next, trajectory of the motion must be of parabolic shape. Clear? So this is the two basic condition of projectile motion. Any doubt? No. Now move further. Now some special case also we have to discuss. Suppose there is a tanker here, and this tanker projected a bomb or bullet just in horizontal direction. So how exactly the ball will move or bomb will move? It has two dimension motion in two dimension. One is along x-axis, and obviously it is initially it was at height, so it will fall down. So one is this direction and another one is in vertical direction. Clear? Okay. Now in any case or any way, this suppose this gun will hit the bullet or fire the bullet, it will fall like this in the same projectile way, or is there some other condition also possible in which it will not follow up trajectory of parabola, or it will be not considered as parabolic motion or projectile motion? Is there any condition possible? So here we are not talking about practical case, just possibility, right? Now suppose it throw a ball with some speed, right? So ball will move like this and fall down on earth surface like this. In the second case we are discussing. Next, again it hit the ball or it throw the ball or fire the bullet with some speed and it's reached some far distance, right? But now it's got some exceptional power and energy, and it very fast way it throw the ball or fire the ball. What will happen? It will move like this, and at place of falling again on the surface of earth, it will complete the trajectory and it will start orbiting around the earth. Okay, can we consider this case when the bullet started orbiting around the earth as a parabolic motion or projectile motion? No, of course no. Why? Because there was condition for projectile motion is what? Shape of this path must be a parabolic. But here shape is what? Circular when it will start orbiting, right? So definitely when it will fire a bullet with too high speed and when it will start orbiting, definitely it will be not parabola. And this also case is possible, right? Yeah, although the velocity required very high, but yeah, case is possible. Another one more case possible, it will hit with more speed. It will the bullet will escape from the gravitational field of earth and it will go somewhere in infinity. Obviously this case also will be not considered as parabolic motion or projectile motion. Clear? But yeah, when the velocity is less, so object again can fall on the earth surface, we can consider, yes, this motion is projectile motion. Clear? Now your question is, with what speed it must be fire the object so it start orbiting or it escape the earth gravitational field. This all calculation we will do in gravitation chapter, not now. Now you just have to understand when it will fire a bullet with very high speed, there is a case when it will start orbiting, and that case will not considered as parabolic or projectile motion. Rest case, when it will fire little slow, so object again fall down on the earth, that we can consider as a parabolic or projectile motion. Clear? Great. So now we have to consider some assumption for basic calculation of projectile motion. Okay, motion take place in uniform gravitational field. So here one assumption we have to take. So while calculating height, range, etc., we'll consider along a small height, acceleration due to gravity remains constant. It's not going to vary for a small height. Okay. Next, we have to consider there is no drag force, which means there is no air resistance or air friction force. Also, we have to consider Earth is flat and it's not rotating, right? Because if we'll consider rotation, we have to consider some pseudo force. Okay. And if we'll consider it's a round shape, okay, then we have to consider this, it's a arc length and all. We cannot consider as a flat surface for range calculation. Clear? Next, acceleration of object along the horizontal direction, we have to consider 0. Obviously, if there is no drag force or no air resistance, it will be 0. Next, only acceleration due to gravity present on the object, and this point is important, where we have to consider object is what? Is a point mass, right? And if object, we can consider an extended object, at that time you have to consider center of mass of the object. So motion of center of mass of the object. But here in beginning, for all calculation, we will consider object is a point object. Clear? Yeah. Now come to this projectile motion and calculation of maximum height. So now see, if we will throw an object, how it will move? It will move like this. So if we draw the trajectory of this, object will start from here and we throw at angle theta with u velocity. It will reach maximum height and again started falling down, right? So it has vertical motion because of vertical component of u, and it has horizontal motion because of horizontal component of u. Clear? And already we learned resolution of vector into horizontal component and vertical component. Clear? Very good. So what is the horizontal component of this velocity, initial velocity? We can consider ux. What is that? U cos theta. Why? Because this is u and this angle with horizontal is theta. Clear? So u cos theta. And what about vertical component? uy u sin theta. Clear? Is it? Now forget about x component. Why? Because we have to calculate height, and height definitely will come in which component or which factor? While considering the vertical motion of object, and initial velocity of vertical component is u sin theta. So discuss only vertical component. Clear? And this u sin theta we considered as positive, and in which direction it is? Upward. And if we talk about acceleration due to gravity, in which direction it is? Downward. So if upward is positive, downward will be negative. So a will be what? Minus g. Clear? Okay. Now at maximum height, what will be the velocity? Consider only vertical, okay, motion. So if we'll throw any object at maximum height, its velocity will become 0, and again while falling down, its velocity will increase slowly in downward direction. Clear? So at maximum height, velocity will be, vertical component velocity will be 0, right? Keep in mind, vertical component of velocity will be 0. Horizontal component of velocity, still we have u cos theta, because there is no resistive force for this horizontal component. So Vy is 0. Clear? Now think we have to calculate this displacement, right? Vertical displacement. Okay. Now which relation can relate this vertical displacement means s. Okay, we can write h or s, both is the same thing. Vy a and uy, right? Initial velocity. Definitely third equation of motion, we can write v square equal to u square plus twice a s. Now v is what? Velocity at maximum height, how much? 0. U means initial velocity in vertical direction is what? U sine theta, and square will be u square sine square theta plus 2. A will be what? Minus of g, and s we can write maximum height h. Clear? So from here if we'll solve, we will get h is equal to u square sine square theta divided by 2g. Clear? Just what we have to use? We have to use third equation of motion, and we got what? Maximum height. Clear? Okay. Now move to the next. Time of flight. So first of all, what is time of flight? Even when you are traveling in flight or something, what is the time of flight? Time during which you are in air. That is your time of flight while air journey, right? Here for object, what is time of flight? Time during which it will be in air. So time from which it's started motion and where it's got ended. This time is time of flight. So here time of flight we will find out in two way, right? So first discuss first way, then we will discuss second way. Clear? So first way, total displacement of vertical direction is how much? See, initially it was at ground, finally it was at ground. So total vertical displacement is how much? 0. So h we can write 0. In how much time? Total time of flight t. Clear? And initial vertical velocity already we know, u sine theta, right? Is it? Now a also we know, minus g. Which equation of motion we can apply? Check. Initial velocity given, time given, h given, a given. Which equation of motion relating these all things? Obviously second equation of motion. H also we can write s. Okay, so s is equal to what? Ut plus half at square. So for this vertical motion, h is how much? We can write h is equal to u sine theta plus half into minus g into total time of flight square, right? And here t also, ut plus half gt square. Now if we'll divide both side by t, this t and this square will get cancelled out. So from here we will get what? And h we can write what? 0. So 0 is equal to, actually first we have to write 0, then t will get cancelled out. So 0 is equal to u sine theta minus half g into t. So from here t we will get 2u sine theta divided by g. Clear? Any doubt? So total time of flight is 2u sine theta by g. Is there any other way to calculate? Think. Yes, definitely. See, this projectile motion is what? It's a parabolic, and it's a symmetry about this point. So means how much time is taking to going up, the same time it will take to come down. So this time will be half time of flight. So t half, right? So you can calculate t half by using what? First equation of motion. At final velocity, y direction is 0, initial u sine theta, a acceleration is minus g. So by this way you can calculate t half. Next, this t half and this t will be same, right? So this also will be t half. So t half you can calculate and multiply by 2, you will get total time of flight, right? So try this way by your own and let me know if you're facing any difficulty. But yeah, definitely easily you can find out by this method also. Clear? Okay, so try. If you are facing difficulty, ask me in comment box. Okay, so now we got total time of flight 2u sine theta by g. Clear? Now we have to calculate range of this projectile. Range means what? The total horizontal distance covered by projectile. This is known as range. So for this range, we have to discuss horizontal motion first time in this calculation. So horizontal velocity means ux is how much? U cos theta. That already we calculated, right? Now, how long it will travel in horizontal direction also till the time it's falling on the earth. Okay, and when it is falling on earth, again this object in total time of flight, and total time of flight is how much? T is equal to 2u sine theta divided by g, right? So now range will be horizontal speed velocity into time of flight. So this we can write now here. Range is equal to u cos theta into 2u sine theta divided by g, right? So u into u will become u square, and 2 sine theta into cos theta, we know that already learned in trigonometry, it is sine 2 theta and divided by g. So range formula we got what? U square sine 2 theta by g. So range is proportional, if u and g is constant, then range is proportional to what? Range is proportional to sine 2 theta, right? So if 2 theta or sine 2 theta is maximum, range will be maximum. Yes or no? So sine 2 theta maximum value will be what? 1. And when it will be 1, we can write this side also. This side we can write. When it will be 1, when 2 theta is equal to 90 degree, it means theta is equal to 45 degree, right? Very important value. So when we will get maximum range? When you will throw object at angle how much? 45 degree, right? For maximum range. Now we remember the first slide. Do you remember? We started when batsman will hit the maximum distance for 6. When the batsman will hit the ball at angle what? 45 degree with horizontal. Clear? When a sportsman can throw a javelin for maximum distance. When he will throw javelin just at angle what? 45 degree. Got it? Yes. So that's why I told you some calculation will help you in sports as well. Clear? So for maximum range we will get angle, at what angle you have to throw the object? 45 degree for maximum range. Okay? Any doubt? No doubt. Now there is one more very important result we can get here. Throw object at angle theta or 90 minus theta, you will get the same range. For theta angle, already we derived the formula. Now for 90 minus theta angle, we have to check the range is coming same or something different. So write down r is equal to u square sine 2 90 minus theta divided by g. So this we will get u square sine 180 minus 2 theta divided by g. If you remember trigonometry, we learned as TC, right? So sine 180 minus theta is also what? Sine theta. So here sine 180 minus 2 theta is also sine 2 theta. So again range we will get the same u square sine 2 theta by g. So here one more result what we got. Either you are throwing object at theta angle or 90 minus theta angle. Clear? The range of projectile will be same. Clear? Very good. If you have doubt, please ask me in comment box. Okay, now see how exactly object is moving with time t, right? So we have to find out actually expression for velocity at time t. Velocity means where we have to consider both component, x component and y component, right? So x component velocity is always constant with time, and it is what? Ux is u cos theta, right? It is always constant with time. It will not vary. Why? Because there is no force that is opposing or increasing the initial velocity, right? But what about the vertical velocity? Vertical velocity for any time t will be what? Initial velocity u sine theta minus gt, right? How we got? By equation, using first equation of motion, u sine theta minus gt. Clear? So x component, if we'll consider as a I cap, this y component, okay, this vertical y component we can consider as a j cap. So final we will get velocity vector at any time t is equal to what? U cos theta I cap plus u sine theta minus gt j cap. Clear? Now what will be the angle with horizontal? So suppose at any time it's making angle alpha with horizontal. So tan alpha is equal to what? Y component means u sine theta minus gt divided by x component u cos theta, right? This is the angle alpha at any point of time t. And if we talk about magnitude of velocity at time t, it's a square of under root square of x component of velocity means u cos theta square plus y square of y component u sine theta minus gt square, right? This is the magnitude of velocity at any time t. Clear? Now see how exactly object is moving during this projection. So here one point you have to understand. We know parabola is symmetrical about the line, right? And here this is symmetrical about this line that is just perpendicular to range, right? So it will be symmetrical about this line means this part will be mirror image of this part, right? So it's a symmetrical. One more thing, with what magnitude of velocity you are throwing the object here, the same with same magnitude object is again hitting the ground, right? Now x component is still same at both point, but here y component at the when it is hitting the ground again is got reversed. It is upward. The same component of y will be but in downward direction. Direction will get reversed. Clear? And one more thing, how much object will take time to go at maximum height? The same time it will take to come down, right? Clear? And why same time? Because we already discussed, if you are throwing just object also, how much time it's going up, the same time it will take to come down. Already we learned this thing in previous chapter, okay, in linear motion. Now if we have to draw the graph velocity in y direction versus time graph, how it will be? Suppose y-axis is velocity axis, velocity in y direction, and this is time. So see, velocity when we are throwing, it has certain velocity, and slowly it's decreasing, and at maximum height it's become 0, right? So velocity will be like this. It will start from certain velocity, and this velocity is what? U sine theta, and it will decrease slowly, right? And at what time it will be 0? Half of the time of flight, that is u sine theta divided by g. Clear? And see, if you calculate slope of this also, you will get what? Minus g. And we know that velocity time graph, slope of velocity time graph is what? Acceleration. And we are getting what? Acceleration here? Minus g. Now, at this point, when at maximum height, velocity will become 0. Again, it's started increasing in reverse direction. So, velocity will continue here, increasing in negative direction. And it will increase till how long? Minus of u sine theta. And time, this time will be how much? The total time of flight, 2u sine theta by g. And if you calculate slope of this portion also, you will get the same slope. How much? Minus g, because we also know acceleration due to gravity is constant in same direction. Clear? Any doubt? No. Now we have to find out displacement in y direction versus time graph. So we can say y versus time graph. So see, it will be like this. Just a parabola shape will come, right? So it will go like this at maximum height. Okay, and what will be the time when it will reach maximum height? U sine theta by g, right? And what will be the value of maximum height? U square sine square theta by g. Clear? See, maximum height is how much? Already we calculated. U square sine square theta by 2g. Sorry, yes, it will be 2g. U square sine square theta by 2g, right? And again, it will fall down on ground. And this time will be how much? Total time of flight, that is 2u sine theta by g. Right? Clear? Any doubt? No doubt. Here we can say finally object came at 0 and it started from 0 displacement. In between it went to maximum height u square sine square theta by 2g. Clear? Now we have to discuss velocity in x direction versus time. There is no force along x direction, so it will be constant with time. And this constant is how much? U cos theta. And displacement obviously will increase with time, right? And maximum displacement will be how much? The range. And range is how much? U square sine 2 theta by g. This is the range. And how long it will move? This time will be how much? 2u sine theta by g. Clear? Good. Now we have to solve one question. In movie Mission Impossible, Ethan Hunt rides a motorcycle, okay, and he launched his motorcycle with velocity 30 meter per second, right, where in horizontal direction, right, from the cliff of height 80 meter. Height was how much? 80 meter. The combined mass of rider and a bike is 200 kg, and we have to neglect air resistance and take g is equal to 10 meter per second. And we have to calculate the speed of motorcycle at ground, right? So here this question we can approach in two way. One, we can solve by energy conservation, and second, we can solve by projectile motion. Okay, so obviously here we will approach this way by projectile motion. So x component will be constant forever. How much? 30 meter per second. Now we have to consider y component of velocity, right? When it will hit the ground, what will be the y component of velocity? So now initial y component of velocity is how much? 0. A we can consider is equal to g, right? And height is given how much? 80 meter. So here we can see the downward velocity and downward acceleration in same direction, right? So both we can consider positive. So now which equation we can apply? Third equation of motion, v square equal to u square plus twice a s. We don't know, so v square, u square is 0 plus 2 into 10 into height of cliff is how much? 80. So it will become how much? 800 into 2, 1600. V square is equal to Vy, actually it is. Vy is how much? Vy square 1600. So Vy is equal to how much? 40. So when the motorcycle will hit the ground, its x component will be 30 meter per second, y component will be 40 meter per second. So finally v will be how much? Magnitude of v under root vx square plus vy square, that is under root 30 square plus 40 square, and when we will solve we will get what? 50 meter per second. So this bike when hit the ground, its velocity or its speed will be how much? 50 meter per second, or magnitude of velocity will be 50 meter per second, right? Now we have to discuss an important thing, radius of curvature. So forget as of now for parabolic motion or projectile motion. Just recall once the circular motion. So if object is moving on circular path at any point, what will be the centripetal acceleration? If it is moving with constant speed v, so centripetal acceleration will be, suppose AC is equal to v square by r. And if we want to write radius in terms of acceleration and v, we can write radius is equal to v square by a. But what is the condition for this a is what? V and a perpendicular to each other, right? That's all. This is the radius of curvature. Whenever we have to calculate radius of curvature, what we have to do? We have to take the square of velocity and divided by acceleration that is perpendicular to velocity, right? So same in projectile motion. If object is moving like this, at any point, if we have to find out radius of curvature, then what we have to do? We have to take the square of velocity and acceleration perpendicular to velocity. So first of all, we will calculate for this maximum height position, right? So for maximum height, velocity will be in this direction and this will be u cos theta, and acceleration will be downward, how much? G only. So at this point, at maximum height, radius of curvature will be how much? U square cos square theta divided by G, right? This is the radius of curvature at maximum height. Clear? Any doubt? No doubt. So yeah, it will ask, most of the time it will ask the radius of curvature at maximum height only. For general point, we will discuss in next lecture. Thank you.